Hello, geometry students. Let's do a quick recap so far. We've been talking about circles and we've been using circle formulas. So far we found the area of a circle using A equals pi r squared. Then we used the radius and we solved. We solved with pi in our answer and then we multiplied and we could either get 64 pi centimeters squared or 201 centimeters squared. That was our area. Then we solved for our circumference. That was the distance around the circle. So here we had two formulas. We had 2 pi r using the radius, or we had pi d using the diameter. Then we added a third formula, which was area of a sector. This used our area formula in it. So pi r squared was in that formula. We found the area of a sector, which was inside that circle. Now we are going to find arc length. So our arc length is going to be the distance from one point of our circle to the other. So the formula that we're going to use here is going to be S equals, and this is how they indicate the area of the arc length. So we are going to use S equals theta divided by 360 times our circumference. So notice we used our area formula for our area of our area of a sector. This time we're going to use our circumference formula to find our distance of the arc here, the arc length, which makes sense because this circumference is the distance around and the arc length is the distance of our arc. So we're going to use the formula for circumference. And in a lot of our examples that you're going to try today, you're going to use this one, 2 pi r. So on the side here, we're going to go ahead and put C equals 2 pi r. All right, so yesterday you started with a question, your essential question, and it asks for the area of a cover of a pool. So it says a local park district just installed a pool that has a diameter of 24 feet. The cover fits exactly on the pool. What is the area of the cover? So the area of the cover, we're going to need the formula A equals pi r squared. So for here, we need the radius. So we needed to cut that in half and make it 12 feet. So we had A equals pi 12 squared. So your answer here should have been 144 pi, or when we put it into our calculator, we have 12 squared times pi, and that should have given you 452.4 feet.
Here you should have feet squared. I made a mistake and left it just feet. So make sure for area it would be feet squared.
Number 1. The circle radius is 10 units. So I know that I can put 10 right here. Find the length of G to Y. So we want to find this arc right here. We're going to use 3.14 or pi and round to the nearest tenth. So our arc length formula is S equals theta over 360 times C. Well, the first thing that we need is C, and we're able to get that because we have 10 units for our radius, and we remember that C equals 2 pi r. So C equals 2 times pi times 10, 20 pi. So our answer for this is going to be 62.8 for our circumference. So now we can plug that into our formula. And we know our theta is going to be the degree of measure here, 47 degrees. We know that that's the same as our arc degree of measure because of what we learned yesterday for central angles. So S equals 47 divided by 360 times what we got here for C, which is 62.8. And when we multiply all of that out, we are going to get S equals 8.2 units for our answer. So whatever the units may be, maybe centimeters or whatever, but in this case, we weren't given a unit. So our answer would be 8.2 units. Let's try another example. Okay, in this example, we are given a radius of 6 units, so I can put that in. And we want to find the length of B to Y. So again, to find arc length, we're going to use that formula, S equals theta over 360 times C. And again, we don't have C yet, so we're going to take that over here. C equals 2 pi r. So C equals 2 times pi times our radius, which is 6. And in this example, our answer is going to be C equals 37.68. Now there's no reason to round here. We can just use the numbers that we have gotten and go ahead and put them in our formula. So S equals 56 for our degree of measure divided by 360. And we are going to multiply that by our circumference that we got here, 37.68. Let's put that right there so we don't confuse anybody. Okay, and then when we multiply it all out, you want to check this on your calculator and make sure that you get the same thing. I'm actually going to get 5.442 or something like that. Remembering we have to round to the nearest tenth, so I look at the number after the decimal. To the right of that, is that 5 or higher? No. So our answer is going to be 5.4 units. All right, let's try one more last example here. This one looks a little bit different because they gave us the degree of measure of our large arc here. But we want to find G to B, because that's what it tells us right there. So the circle has a radius of 10 units. So our 10 units. Find the length of G to B and use 3.14 or pi. Round to the nearest tenth again. So we have our formula again, S equals theta divided by 360 times C. Well, C we don't have again, so C equals 2 times pi times R. So C equals 2 times pi times 10. And I seem to think that we did this one already, but our answer here is going to be 62.83. So I'm going to use this one in my formula. Now, if you notice our theta, we need theta for here. We need this degree of measure, but they gave us 296. So in order to find that degree of measure, we know that the whole circle is 360. And I'm going to subtract what they gave me, 296. And that's going to give me the number 64. So that is our degree of measure that we're going to use for our formula. So 64 divided by 360, and we will multiply that by what we got here for C, 62.83. When we multiply all that out, I put that in parentheses because if you do this all in one swoop, you might get the wrong answer. So let's put those in parentheses and make sure that we do that first. So our answer is going to be S equals 11.2 units for our arc length G to B. So I could write it like this. Arc GB equals 11.2 units.